So, hello students, welcome back to the new video lectures. And in the previous video lectures, we have started a new chapter that is work and energies. And in the previous video, we have discussed what is works, and we have also learned some ideas about the energies. Okay, so you see, in the previous video, we have learned that what is energies, right? Energy is what? It is the capacities of doing some works. Okay, so energy is SI unit of energy is considered to be the SI unit of energy is considered to be the joules. Okay, SI unit of energy is also considered to be the joules. Okay, so in this video lectures, we will be discussing the two forms of energy. Forms of energy. There are different forms of energy. One is gravitational energy. Also, you can see frictional energy is there. Okay, mechanical energy is there. Potential energy is there. Internal energy is there. Kinetic energy is there. Okay, so chemical energy is yours. Okay, so there are different forms of energy, but we are not going to discuss all these forms of energy. We will only discuss the two forms of energy. One is called as a kinetic energy. Okay, and another is known as the potential energies. Okay. So what does kinetic energy means? Energy passes due to the movements and motions of an object. Okay, energy passes due to the motions of an object. Okay, energy passes due to the motions of an object is what we call as a kinetic energy. So whenever the object is moving, okay, energy passes due to the motions. Okay, energy passes due to the motions. Whenever energy passes due to the motions of an object. Okay, of an object. Energy passes due to the motions of an object. Whenever the object is moving, okay, there passes the kinetic energy. The more object, if the object keep on moving continuously, that means more speed is there. That means more kinetic energy will be there. That means that is what is it. If more kinetic energy is there, that means more speed will be there. Okay, so the energy passes due to the motions of an object is what we call as a kinetic energies. The next topic is what we call as a potential energy. Do you know what is the word potential energy? You might have come across the very word that is potential. You might have come across that your teachers been given a compliment that you have a really great potential. Okay, you have a really great potential. What does that potential mean? Okay, that means the potential means you have a great potential. You have a really great potential in the fields of football. You have a great potential in the fields of studies. You have a great potential in the fields of singing or any activities. What does the potential means? Okay, why does the teachers relate, or why does somebody said you have that potential? That defines us that tomorrow you might be doing, in the future you might be doing something great in that field. Okay, so the potential energy in terms of science, in terms of physics, when you talk about a potential energy is an energy possessed by the object when the object is in the rest. Okay, when the object is in the rest, okay, they possess without the motion, if the object is not moving, but still they possess some energy, and that energy is what we call as the kinetic potential energies. Okay, now if I say, when I take the spring, okay, and if I try to stretch it out, if I try to stretch out the spring, okay, and ultimately if I leave it, okay, then they smash back, okay, to their original position. Okay, so in order to return it back to the original position, they possess a lot of energies. Okay, so what does it mean? You see, when I pull up, there was an energies. Okay, when I pull up, it was pull up with my energies. Okay, I give my energy to stretch up the spring. But the moment I leave it, that means the spring returned it back to the original position with the high speeds. Now the question comes from where these energies have been get. Okay, we have also learned that energy can be neither created nor be destroyed. But from where this energy have been obtained? That is the questions. Okay, so the questions, in order to answer the questions, that very question is that with the energy process, the energy that exerted into regain the original positions, okay, the original shapes by the spring is because of the potential energy. Okay, now let's talk about one thing is that the moment if you talk about the hydro project dams, okay, if you try to close the waters in the one side, Okay, if this is the waters, okay, the moment if I leave these waters, okay, the moment if I left these waters, they flow with a high speed. So they possess a kinetic energy. When they flow, they possess a kinetic energy. So you see, before we flow, that means the water is in the form of state, in the form of rest. Okay, there is no energies. Okay, but ultimately if I keep up, that means the water start falling off. Okay, that means they form a kinetic energy that passes, because the kinetic energy means what? The energy passes due to the motions of an object. Okay, so the moment the water is open out, that means in that with a high speed, they possess an energy. They give us the energies. Okay, so from where these kinetic energies have been released. Okay, so when the water is in the race, when the water you are storing, okay, when the water is storing in the dam, okay, when the water is storing in the dam, this water start releasing the potential energies. Okay, they start generating the potential energies. Okay, the moment if I open up the well, that means the waters will come out with a high speed, with a high kinetic energies. Okay, so that means what? A potential energy is an energy, okay, which passes due to the more when the object is at the rest. Okay, the potential energy is possessed by the object, okay, by the virtue of its position. So object energy possessed by the virtue of its position is known as the potential energy. Energy possessed, okay, energy possessed by the virtue of its positions. Okay, by the virtue of its positions. Okay, it's what we call as a kinetic potential energies. Okay, so what is the kinetic energy? A kinetic energy is an energy possessed due to the motions of an object, whereas a potential energy is an energy, okay, the energy possessed by the virtue of its position. By the virtue of its position is what we call as a kinetic potential energies. Okay, energies, okay, present, okay, by in it, energy present in the object, okay, energy present in the object, okay, by the virtue of its position is what we call that energy, is what we call as a potential energies. Okay, so let's try to understand, let's try to derive the formulas one by one. Okay, let's try to derive what will be the formulas of kinetic energy, what will be the formulas of potential energy. We'll discuss one by one in this video lectures. Okay, so let's go with the kinetic energy. Kinetic energies. Okay, what is kinetic energies? We know the kinetic energies, okay, is an energy possessed due to the motion of an object. Okay, when the object keep on moving, they possess the kinetic energies. Okay, now let's express the kinetic energy in the form of equations. Let us try to find out the kinetic energy in the form of equations. Okay, so let's consider an object. Okay, let's consider an object. Okay, let us consider an object. Okay, let us consider an object A. His mass is m. Okay, now you're applying a force on it. That means object will displace for some distance. Okay, the object will displace. Let the mass of the object be m. Let the mass of an object be m. Okay, let the mass of an object be m. Okay, let the mass of an object be m, moving with a uniform velocity, that is moving with uniform velocities, that is u. Okay, uniform initial velocity, that is u. Okay, so let this object displace. Okay, let the object at the very beginning, the object, this is m. So let the object is remain at this position, that is let's say x, and it displaces a new position, that is let's say the same object, that is a mass, the new position, that is y, and distance from here to here, it is x. Okay, so when we apply the force, okay, when the force applied, okay, when the force is applied, when the force if is applied applied to the object, okay, then the object displace, then the object displace at s displacement. Okay, when the object displays at s distance, okay, or object displays at okay, the object displays at the object displays at s distance. Okay, that means what? That means what? That means you are applying a force. That means therefore, okay, force is equal to what? Force F is equal to mass into acceleration. That is what we are getting. This is our equation 1. Okay, now when you are applying a force on an object, that means what? When you are applying a force on an object, that means what? There will be a work done. Therefore, work done is equal to what? Work done, W is equal to what? Force into displacement. Yes or no? Now, we know that the work done, force is what? Mass into acceleration into S. Okay, so this is our equation number 2. Okay, so this is our equation number 2. Work done is equal to what? Replacing by the force is equal to ma, in place of F, you are getting ma. Okay, now using the second motions, okay, using the third equations of motions, okay, we know the third equations, okay, from third equations of motions, okay, we know the third equations of motion. What is the third equations of motion said? V squared minus U squared is equal to 2as. Okay, what is the third equations of motion? V squared minus U squared is equal to 2as. Okay, so from here we can say 2as is also equal to V squared minus U squared. Now I want to find the values of s. That means what? S is equal to what? V squared minus U squared is equal to what? 2a. So we got the values of s also, equation number 3. Okay, from equation 1 and 2, from equation 2 and 3, from equation 2 and 3, okay, so from equation 2 and 3, work done, okay, work done will be equal to mass, work done will be equal to mass into acceleration, and we know s, in place of s I can write V squared minus U squared divided by 2a. So if I reduce this a and a, that means my W will be what? Mass into velocity squared minus U squared divided by 2. Okay. Okay, so 2 and 2 cancel out. I think you're clear up to here. So I'm rubbing this one. Now, W will be equal to what? 2 and A cancel. That means what? Mass by 2 is equal to V squared minus U squared. Okay, so we know that work is also another forms of energies. Okay, since we know that work is also another forms of energies. Okay, work done is equal to the change in kinetic energies. Okay, so let's say let initial velocities, okay, or let starting velocity u is equal to 0. Okay, 0 meter per second. That means the object is starting with a 0 meter per second. The object is starting the initial velocity if the object have displaced with the 0 velocities. Okay, so means starting velocity it is 0. That means my work done will be equal to what? Mass by 2. Okay, velocity minus 0 squared. So my answer will become what? Work done is equal to m by 2 v squared. Yes or no? So this is what we are getting. Okay, and since the work done is there, means the object have moved. Okay, we have learned what is the work done. Okay, when do we say the work is done? The work is said to be done when the object displaced. Okay, when there is a force, and with that force, if the object displaced its position, then only we can say the work is done. Okay, so that means that object is moving from new position to the from old position, the initial position to the new position. That means they possess the kinetic energies now. Okay, just try to understand the concept. Okay, the work done is what? A work done, okay, is said, or a work done is said when object displaces its position. So object displaces its position means what? Object is moving. Okay, so when the object is moving, that means they possess a kinetic energy. That means what? So from here we have learned that therefore work done work done is equal to, okay, is equal to change in kinetic energy. Okay, so therefore, which implies that we can write in place of work done, that means we can write kinetic energy. Kinetic energy is equal to 1 by 2 mv squared. So in place of work, in place of this work, we have replaced it by kinetic energy, because work done is also in terms of kinetic energies. Okay, so kinetic energy possessed by the object, okay, object of mass, this of kinetic energy possessed by the object of mass, okay, and is equal to 1 by 2 mv squared. So that means what? Kinetic energies, okay, kinetic energy is directly proportional to mass and directly proportional to the velocities. Okay, so if the object, if the mass is high, okay, if the mass is high, okay, I will just take the two pieces of the object. One is a paper, okay, another is a stone. Okay, so if I let it from the, if I let it to move from the up, from the very high, when it impact on the ground, whose energies, whose force will be more? The stone will be more. Why? Because their mass is high as compared to the piece of paper. Okay, so they are falling on the same velocity. But the impact of the stone will be high because their mass is high as compared to the stone. Okay, so from here you see, try to understand this one. Okay, this is very much important. Okay, if the kinetic energy is, if the mass is more, okay, if the mass is more, kinetic energy is directly proportional to the mass. Okay, leaving the velocity as same. Okay, velocity is same. Okay, velocity is same. Then let's say, if let's say condition number 1, case number 1. Try to understand. If kinetic energy is directly proportional to the mass, okay, velocity is same. That means for m, let's say two objects, let's say object A and B. Okay, let's take object A and object B. Okay, let's take object A and object B. If their velocity, that means VA and VB are same. Okay, velocities are same, but their mass are different. Let's say mass A is greater than mass B. Okay, mass of object A is greater than mass of object B, and their velocity is same. Whose impact will be more? Whose kinetic energy will be more? Obviously, the kinetic energy of object A will be greater than the, therefore kinetic energies of object A will be greater than the kinetic energies of object B. Okay, that means what? That means what? If, as I already told you, let's take one paper. Okay, this is a stone, and another, this one is a piece of paper. Okay, and I will let it to fall from the very high. Let's say this is the ground. Okay, or I'll let you to lay down on this ground. Okay, now I will try one stone and the papers from here. Whose impact will be more? Whose energy will be more? Obviously, the stone will be more. Okay, though they are falling on the same speed. Okay, but the stone will be more impact on you, right? So that means what? If mass is more, okay, then the velocity is same. That means kinetic energies will be more in terms of the object which have a more mass. Okay, similarly when you talk about the case number 2, okay, leaving case number 2, if I talk about case number 2, okay, leaving the object, mass of object A is equal to mass of object B. Now object, their mass are same, but the velocities of object A is greater than velocity of object B. Whose impact will be more now? The impact of the object A will be greater. Okay, so that is what I'm going to say. The impact of the what is it? The kinetic energy of the bullet is high. Okay, while though their mass is very low, but their velocities are very high. Okay, so that means what? Kinetic energies of a bullet is very high, is compared to when you throw the stone. Okay, you're taking the mass stone and the bullet, and the bullet is fired from the gun, and the stone you have thrown it from your same process. You are throwing from your hand. Okay, so when you fire the bullet from your gun and when you throw the stone, okay, the bullet, when you fire the bullet from your gun, they will penetrate. They will go with a high speed, right? They will go with a high speed. When you go with a high speed, okay, when you go with a high speed, that means what? The kinetic energy is more. But if you throw with a stone, though their mass are same, but the stone that you have thrown, it will impact less, because their velocities are less as compared to the velocity of the bullets. Okay, so kinetic energy is directly proportional to what? Is directly proportional to the mass, and kinetic energy is also directly proportional to the velocity squares. Okay, squares of the velocity. If the mass is increases, kinetic energy increases. If the velocity increases, kinetic energy also increases. Okay, so this is all about the kinetic energies. Okay, so this is all about the kinetic energy. We also define kinetic energy in this way: Ek. Okay, Ek is equal to what? 1 by 2 mv squares. So this is all about the kinetic energies. Okay, so we can write kinetic energy is what? Half of mass into velocity squares. Okay, so I believe you have understood this topic, the kinetic energy. Okay, let's go with the next video, the next topic, that is potential energies. Okay, let's go to the new topic that is called potential energy at potential energy of an object at height. Okay, we have known what is potential energies. Okay, so potential energies are those energy which passes due to the potential energies are those energy which passes, okay, which is possessed by the object by virtue of its positions or configurations. Okay, is what we call as a potential energies. Okay, so now when I say the object is lift to some height, okay, so the object is lift to some height. If the object is, this is A, object A have lift to some height, let's say the height of the object is, the height of this object is what? H. Okay, from the ground level. Okay, you have lift the object to some height. What will be the force on this object? What will be the force on this object? Potential energies. Potential energies. What will be the force on this object? Okay, so let the mass of an object be m. Let the mass of an object be m. Okay, now what will be the force on the object? Okay, force on an object, force on an object, force on an object, F will be what? It will be mass into acceleration. But our acceleration, we are not applying anything. We are not applying any any movements, right? There's no rate in change in velocity. We are just lifting them. Okay, we are just lifting them. Okay, so what is it? What will be the acceleration? Our acceleration, since we are not giving any derivative acceleration, that means what? Our acceleration will depend on what? Acceleration due to gravity. That means what? Force, okay, applied on the object will be equal to what? F is equal to mg. Okay, so now we know that work done is what? If there is a force, that means there will be some work done. Okay, so let's see what is the displacement. Okay, so work done is what? Force into displacement. And which implies that work done is equal to force into displacement is what? From here we are displacing to this level, that means your displacement will be h. So work done will be equal to what? Mass into gravity into h. Okay, that means that work done on the object will be what? Mass into velocity. Okay, mass into acceleration due to gravity into height. Okay, so this work done, okay, since we are changing them but we are not letting the object to move, that means the object is not moving, the object is in the stationary, that means the object is in the rest. Okay, but still there is a work done on it, that means that work done is what? The object is in the rest, that means what? The work done is equal to the work done is equal to the energy, the kinetic energy. The work done is equal to the potential energy. That means what? Work done will be equal to what? PE, work done is equal to what? Potential energies. Okay, that means what? PE will be equal to mgh. Okay, what is it? PE will be equal to mgh. Okay, so potential energy of object is what? Mass into acceleration due to gravity into h. Okay, acceleration due to gravity remain constant, but m is what? Mass, potential energy either depend on mass, okay, and potential also depend on height. Okay, the more you take the object higher, okay, that much potential energy they will get. Got it not? So if the mass of the object is high, that means more potential energy is there. That means that is what I said. Potential energy is directly proportional to mass, and potential energy is also directly proportional to the height of an object. Okay, so here you see the potential energy does not depend. Remember, does not. Remember, potential energy, okay, does not depend on the path. Okay, that means let's try to understand. Let's try to understand this. The potential energy does not depend on the path. Okay, the potential energy will not depend on the paths from where the object have moved, lifted. Okay, so let's discuss this one here in the pictures. I think you're clear about this one. How this potential energy, and yes, so this is the formulas of the potential energies. Okay. So let's try to understand what does it mean that potential energies does not depend on the height part, but it actually depends on the height of the object from the ground levels. Okay, so potential energy does not depend on the path, but it only depend. Okay, it only depends on the height from the ground. Okay, so what does it mean that if you are this is a ground level, now your friends are lifting. Okay, your friend is lifting the object from here directly to this. Okay, directly the object you are lifting from the ground to this. Okay, so this is your height. Now you are lifting, okay, the object, okay, in this direction. From this object you are lifting. Okay, then you have moved up this tool. Again you have sent this side. Again you have moved this object here. Again return it back. Again move the object here. That means your object, both of you are on the same height only. Okay. Your height from the grounds are same only for both cases. But what did you do is that you have moved the object from here, again you move this side, again you move up, again on the left side, again you lift it higher again on the same height of an object that your friend has put. Okay, and do you think that the potential energies here and potential energies here will be same, different or same? Thought their height are same. Do you think the potential energy will be same or different? No, the potential energies out here, for both the cases, the potential energy will be same. Whether you are taking the object in a different path, this is what we call path. Okay, you are taking the object from moving from this direction to here, and then you have changed the directions here again and again, right? So whenever you are changing the directions here again and again, you are moving the object here and there. Okay, but your height is same as same height. Okay, you're lifting the same height as your friend have lifted. Okay, the potential energy on the same object will be same, though you have taken in a different path also. Okay, though you have taken a different path length also. Okay, so the potential energy, that is what it's saying. A potential energy does not depend on the path length, but it only depends how high it is rise up from the ground. Okay, how high it is rise up from the ground. Okay, so this is all about the potential energies and the kinetic energies. Okay, so we'll try to understand what is a potential energy. A potential energy is energy possessed by the object by its virtue of an positions or configuration. Okay, next, what is the kinetic energy? The kinetic energy is energy possessed due to the movement of an object solely. When an object is moving, that means they possess a kinetic energies. Okay, so these are the two different forms of energy that we have learned in the class 9. In the higher classes, you will learn different forms of energies again. Okay, so this is all about the kinetic energy, potential energy, and the next is that are the various energy from interconvertible. Yes, energies are interconvertible. Energy can convert from one to another. Okay, so this is an example. So whenever the waters is lifted, okay, whenever the waters, as if it's talk about a spring, okay, whenever you are putting the springs out here, before the object or spring was in the potential energies, and when you stretch it out, they convert, the object move. That means they convert into kinetic energy, and when you leave it the spring, they regain its original position. That means what? From the potential energy again, it returned it back to the kinetic energy, and after the kinetic energy again, it returned it back to the potential energy. That means what? Energy can be convertible from one to another. Okay, another example that we can understand is what? A dam. Okay, in a water dam, let's say this is the ground level and this is a dam. Okay, in a water dam, whenever you are storing the waters, okay, so these waters which is in the race possess the potential energies. Okay, the water which is in the rest that possesses the potential energy. The moment if you open up the well them, that means they will move out. The water will move out in the form of, okay, the water will move out from the dam. That means they possess, the object is moving. Okay, that means they possess a kinetic energy. Okay, they possess a kinetic energy. Means at the very beginning when the water was under the dam, when the water was storing, they possess the potential energy. The moment water let it to flow, okay, that means when the water flowed from the ground, from the dam, that means they possess a kinetic energy. Okay, next thing is what? Your bow and arrow, right? So the bow, that and arrows, okay. So the bows and arrows, okay, I'm writing bows and arrows, okay. So the moment when you are stretching the bows, okay, so this bow will have a potential energies. The moment you release it, the arrow, that this arrow will gain a kinetic energy from the potential energies. Okay, so from here we have learned that energy can be convertibles. Okay, energy can convert from potential energy to kinetic energy, and from kinetic energy again it will convert into mechanical energy, and from mechanical energy it can also convert into electrical energy, chemical energies. Okay, so energies are convertibles in nature. Okay, but energy cannot be created. We cannot create the energies. Okay, we can only convert the energies. Energy can be transformable, but energies are neither created, cannot be again destroyed also. Okay, so this is what is called conservations of energy that we are going to study in the next video lectures. Okay, so this is all about the video. This is all about the topics of kinetic energies and potential energies. Thank you. Bye bye.